Okay, let's talk about proportions and cross multiplying. I want to give us a good visual representation of what's going on. So let's take a square and cut it into 4 equal pieces, and let's shade in 1 out of those 4. Okay, so that is a way of writing 1/4. Now if we come along and cut that square in half in the other direction, we can see that what we did was we doubled the number of pieces that are shaded, but we also doubled the total number of pieces in the square. We now have 2 shaded pieces out of 8. So the proportion is the equation where we talk about one fraction equals another fraction. Okay, the number we multiplied by here has a special name. It's the constant of proportionality. And the key thing is whatever we multiply by in the numerator has to be the same number that we multiply in the denominator if we want to get 2 equal fractions, a true proportion equation. All right, so let's apply this to cross multiplying. You have seen before that if you do 1 times 8, and then you multiply in the other direction, 4 times 2, those two things should be equal. But the question is, why? Why does that actually work? And what we need to do is think about where these things came from. The 2/8 came from the 4 times 2 in the bottom. We're actually saying 1 times 4 times 2, and in the other direction, we're actually saying 4 times 1 times 2. In each of these, there's a 1, and there is a 4, and because we have a nice constant of proportionality that is the same for numerator and denominator, there's also a 2, like the same number on both sides of our equation. So 1 times 4 times 2 does equal 4 times 1 times 2. So that is why cross multiplying works, and I think it'll be even more clear if we do an example of something where they're not equal. Let's say we get handed the question, does 1/4 equal 15 50-seconds? It's too hard to draw, but we could look at it from several different directions. First of all, the constant of proportionality. To get to 15, we would do 1 times 15. What about 52? I might have to check my calculator for that. It's actually 4 times 13. So because it's not the same number in the numerator and denominator, we know that's not going to be true, but let's look at multiplying it out. 1 times 52, does it equal 4 times 15? 52 does not equal 60. And another way to look at it would be, where did that 52 come from? Well, it was 4 times 13. And where did the 15 come from on the other side? It was 1 times 15. So we have some things lining up. They both have a 1, they both have a 4, but because it's not a constant of proportionality that's the same, we don't get to equal totals. 52 is not the same as 60. Okay, let's see how that would apply if we're solving an equation. A lot of times it's really not obvious what the constant of proportionality is. 16 times something gives me 12. It's a decimal or a fraction of some kind. Whatever it is, I would use the same exact number to multiply 3 times that to give me x. So a shortcut that many people like is to cross multiply. 3 times 12 gives me 16 times x. We can simplify it down. 36 is 16x. Divide through by 16, and we get 2.25 equals x for our solution. The nice thing about that was we were able to do it without needing to find the constant of proportionality, and that's fine. We just got all the way directly to x. If you want to find the constant of proportionality, that's another option. We could say, well, 16 times something gives me 12. So I could go backwards and do division. 12 divided by 16 would give me the number, and it's 0.75. So 16 times 0.75 to get to 12, and then if I come in the other direction, 3 times 0.75 will give me x, and we've got 2.25 again. Same answer, two different approaches.